First thing to learn about Nmap is the help switch. So for example, Nmap-H gives us a list of all of these switches which correspond to a different kind of scan for different purpose. So you see we have here -F for evading firewalls, for decoy IPs, spoofing IP addresses. So every switch has its own objective that could be used in our scenario or could not be used in this scenario. So we can clear now, and the first type of scan is the stealth scan. We type sudo nmap, and we type target. Okay, so what's the purpose of stealth scan? Presumably, the stealth scan would make you evade the firewall. Okay, so if you have firewalls, intrusion prevention systems in place, this type of scan is the first step in evading firewalls. Of course, don't get this as a one piece to evade the firewall. The Nmap scan or the Nmap command syntax to evade firewall is more complex than that. But to understand the purpose of each switch, we've got to try them one by one, individually or separately. So first we start with the stealth scan and we hit enter. And we're gonna do more than one scan. So basically here, new tab, or let's split this. Okay, the second type of scan is the UDP scan. Okay, so we got the first result. So we have, based on the stealth scan, we get the number of ports open, which are 2. We have 2 ports open. One is on SSH and one is on HTTP. Okay, let's now try a different type of scan. So the second type of scan is the UDP scan. So we type the same syntax. Okay, so the nmap-su, that's the switch for UDP scan, and we type the IP address. All right. As you can see, the UDP scan has not yielded any meaningful results. Why? Basically because these ports are TCP ports. And since the machine is not running UDP ports or UDP or services that rely on UDP ports, the scan has not succeeded. So as you can see, nothing. So that's why it's saying use try PN. It thought that the target is or the target machine disabled the ping discovery. That's why it recommended us to use -PN, which is the switch used for disabling the ping discovery. Okay, let's try how we can scan for OSS. So basically the same syntax, but we replaced SS with O. This is for detecting the operating system. How about scanning for the version of the services running on port 22 and 80? This is useful if you want to enumerate for vulnerabilities. So we type sudo nmap-sv, enumerating the versions of the services running, and we type the target name, IP. Right, so we can see here the results of the OS detection. And the OS detection so far was the most detailed scan. Why? As we can see, we have listed the open ports and the services, right? And we can see a speculation for the running OS. So here it's saying OS detection performed. Let's see above here, fingerprint, OS. So here, Linux. So the running target is Linux. And here we can see another speculation for Windows. But most the first one is Linux, which is most probably it is the OS running on the targets. So that's the OS detection scan. Let's go to the right here, and we see the result of scanning the versions. So you can see here, we have returned the number of open ports, the services, and the version of the server or the application running, Apache HTTPD 247. This is very useful if you want to use search exploit or find an exploit that matches the version. OpenSSH version 66.1p1, v1.2.2. Okay. Right. So far we have seen how to do stealth scan, how to do OS detection, how to scan for versions, and how to scan for UDP. Right. So the next thing is doing the verbose scan. The verbose scan is when you want to display what Nmap is doing, right? Instead of waiting for the results to pop up, you see what Nmap is actually doing in the pipeline. So we type sudo nmap, and we don't use any switch, just use -v for verbosity, and type the target IP. as you can see here, the output is being displayed, right? While Nmap is scanning. So as Nmap scans the target, we see every single step being done, every single stage. What about very verbose scan? Very verbose scan, instead of 1V, you type 2Vs. Okay, now let's get to a point where if you want to save the outputs, right, into a file, readable file, common format, as outlined in the question. So how do we do that? Let's say, for example, we want to scan for sudo nmap, scan for versions, enumerate the versions, enumerate the OS, and do stealth scan. No, this couldn't be actually. Okay, OS detection and versions, and save the output to XML file, for example. OX and the target name. And here we need to specify, let me do this. So here results, specify the file name, and here specify the target. As you can see, the file has been created here, results. The file will host the details of the scan. So if we, for example, type cat or nano results, we're not going to do that now. We're going to just wait for the scan to finish and then open the file. Let's examine the file, nano results. So this is the Nmap scan result, but in XML file format, right? And you can also open this in the browser, I guess. Let me open it. So this is the scan result in XML format. All right. So now we do the aggressive scan. The aggressive scan is used specifically in white box penetration testing when your client actually knows you are scanning their network, right? Plus, or additionally, they whitelist your IP address in their intrusion prevention system or firewall, if any, right? So that's when you use the aggressive scan in the white box testing, or if you don't care if there is a firewall or not. Sudo nmap -a 10 10 10 15. Okay. Now the next step is to set the timing. So basically the timing, let's talk about the timing. So sudo -nmap -t, insane level is T5, right? And we type 10 10. Now for the timing, there are 4 levels, 5 4 3 2 1. And these levels differ by or affect the speed of your scan. Okay. Now let's type enter. So the aggressive result scan has finished. So we have the open ports. As you can see, there are we have too much details about every port, every service. This is the host key, RSA, CSA, and these are details about the HTTP server. You can see the robots file, the login header, then vulnerable web app. More details about every service running. That's the purpose of aggressive scan. Now 5 has finished, and the result of the timing of the scan doesn't affect the actual result. It only affects the speed. The third question, scanning specific ports. So for example, sudo nmap, if we know that the target is running a web server or SSH server, so we want to scan only that server, only that port. We use -p, okay, and we type the port name, 80 for example, and the target. So it's going to scan only port 80. As you can see, the results only port 80. So scanning all ports. Instead of 80, we do type -p and we hit enter. It's going to scan for all ports. Usually this scan is very time consuming. Okay, so it's going to be your last resort in your penetration testing or in the enumeration gathering phase. Okay, so for scanning, for using the scripting engine, we're going to do, for example, sudo nmap /script. That's the switch. So you either specify now the location of the script, for example, user share. It was in, let me remember, I could remember the location of the now scripting. Let me dark. locate Nmap. Okay, so it is user share Nmap scripts. So for example, we define user share Nmap scripts, and let's use something from there. Locate.nse grep HTTP. So we have something about this. We can choose to use a specific Nmap script to scan the HTTP server. For example, HTTP headers. Let's use this. We type the name of the script and the target. I'm going to end the port scan because the all ports is going to be very long. Let's jump to the next one. So in order to use the vulnerability switch in the Nmap scripting engine, we use -- script vuln. It will try all of the Nmap scripts categorized under vulnerability, right? To scan for vulnerabilities, I mean. So you hit enter and you get the results. Let's scan. Let's examine the result of the Nmap scan for the HTTP headers. So as you can see, we get the HTTP headers of the web server: date, server, the cookie, expires, cache control, all kind of headers that are used in the web server or the Apache web server. To disable the ping discovery, we type sudo nmap-pn 10 10 10 15. When do you need to use the ping discovery? Disabling the ping discovery. You would use that if you know that your target has disabled the ping discovery of their server, right? So you use the switch to scan without using ping. We can use that switch, right, alongside other switches. For example, sudo nmap-sv enumerate for versions, disable ping discovery, and be aggressive, and timing 4, and output the results to specify the target first. Output the results to no ping. No ping here. Okay, I want to open this with Google Chrome. No. Okay, this is good. Okay, so let's read through the results in the file here. So it's asking for the version of the SSH server running. So as you can see, we have service name. Where is the mouse? Okay, so here SSH product open SSH version 66p1. Okay, let's go down. These are the OS detections, fingerprint. So here, nothing. Let's go up. Yeah, this is not the scan for vulnerabilities. This is our customized scan. Let's run one here. Oh, we have one actually, has finished. So this was the scan for vulnerabilities. Let's see here. Let's go down and we see in the details of the web server here. We see the flags, the details of the headers. We see some issues in the HTTP server. Among them are HTTP CSRF couldn't find any CSRF vulnerabilities. Fine. HTTP DOM-based XSS couldn't find any XDOM vulnerabilities. DOM-based XSS. These are it was enumerating for the vulnerabilities, and here it outputted the results. So we can see here one, HTTP slow LoRes check. It is vulnerable, slow LoRes DOS attack.
So let's scan the machine now. Okay, reveal all the ports first. So nmap -sn. So the host is live. Let's now do a general scan to reveal all the ports. How many ports are open? So as you can see, we have 1, 2, 3. We have 3 open ports. Now, if you want to use your Nmap skills, you can actually ping these ports, connect with these ports without the need for Netcat. Okay. Now, if you want to use Netcat, just type Netcat. We connect to the first port, 22, 22. So it is an SSH server, open SSH. Okay, let's connect with the other one, 31, 337. So as you can see, we are connected to this port and we have this. In case I forget, user pass, and we have username and we have password. It's clearly that these credentials are supposed to be used to log into the SSH server, either on this or this one. Now, except Netcat, how we can get this information using only Nmap. So let me get back here to my notes. As you can see, we have first to launch a service scan. Okay, now in addition to the service scan, we have to perform aggressive scan with -a, and of course we can harness the script scan -sc. Right, okay, so now we go back, sudo nmap -sv service scan -sc -a, and there you go, the IP address. Okay, let's take a look now at the output. So we have now more details about every port. So 22, and we have OpenSSH, which is running also on the same port, 2222, the same server. Now regarding this port, the last one, 31, 337, based on the scripting scan or the scripting engine scan, as you can see, we got all of the details here. In case I forget, user pass, so it performed some sort of binary grabbing on the port. Okay, now let's launch the scan again, but we will not use the hosted script scan. Okay, we're gonna use only aggressive scan and divergent scan. Let's see how it's gonna play. Okay, let's go back, and again we get the same results, we get the same output. So it's optional to use this switch here, the scripting engine scan. It is optional. Okay, if you use only the version scan or the aggressive scan, you'll be able to reveal all of these information. Now let's get back to the Nmap scan, and let's see, you want to perform some sort of stealth scan. Okay, let's say this is a machine that's protected behind a firewall and you don't want to alert the firewall, so your scan needs to be stealthy. Let's find out. So let me check my notes here. See, the stealth scan can be performed with the option -ss, and here we control the speed of the scan. A null scan can be performed as well. A fin scan can be performed, -t1. Okay, let's go with the null scan. So here, -sn, -t1. Let's see if we will be able to reveal the information that we have revealed so far. I know the machine is not protected behind firewall, but in case it is protected, you have to use the stealth scan, or you have to avoid the noisy scans. Let's see here. Okay, we will not wait for this scan to finish. We have now these credentials. Let's log in now to the machine. Open up a new tab. Ubuntu at and the password. So the password is here. And as you can see, we are logged into the machine using the SSH server. Now, PWD, we are under home Ubuntu, ls, nothing in here, cd back, ls-la, and we have another user. See what happened. So as you can see, the null scan hasn't given any output yet because it's so slow, -t1. We can increase the speed of the scan if we increase this to 3 maybe. Let's try now. It is not part of the challenge, guys. It's just a bonus. So as you can see here, we got the same result, but we are not able to get the same output we have here, the same details. So in this case, we may have to go back and type -ss stealth scan, see if the stealth scan can give any result. Okay, 3 open ports. All right, let's now add the version scan. And yes, we got the same results. Okay, let's see here. So we have this port. Now, as you can see, it didn't connect to the port. but we extracted these details. We have, as you can see here, user, pass, Ubuntu, but you have to strip the unnecessary characters. So user is Ubuntu, and this is the password. And the first type of scan that we're going to cover is the TCP Connect Scan. So basically, you can conduct TCP Connect Scan with the following command. Make sure before running Nmap that you have sudo privileges, or you have a user that can run commands as sudo. Now, TCP Connect Scan doesn't need elevated privileges, and it's worth noting that the TCP Connect Scan is the only type of scan in Nmap that's available under low privileges. So you can conduct -st without needing to be root or any other privilege user. Anyway, so nmap -st, and then we put in the IP address of the host. This will conduct a TCP Connect Scan, meaning that we will send a TCP three-way handshake, and depending on the response of the host, we will determine what are the open ports. That's how Nmap works when we use TCP Connect Scan. Now, TCP Connect Scan is a normal scan. It's not a stealthy scan, and it is a scan that is visible to system administrators and firewalls and network intrusion detection systems. As you can see, we discovered these open ports. Note that we have the ports that are open, the state, and we have the service running on the port. We don't have yet information about this version and other fingerprinting information about each service. If you have watched my videos on while we solve machines and CTFs, you may notice that we use -sv to discover the version of every service. Now, I'm not going to confuse you guys. So basically, that's the first type of scan that we do to conduct a TCP Connect Scan and discover the open ports. The other type of scan is the Stealth Scan. Okay, so basically, let's talk a bit about the Stealth Scan while the machine IP pops up. So basically, the Stealth Scan, first, it requires root privileges. As you can see, I'm not executing the scan with sudo because I'm already root on the machine. So make sure when you want to conduct Stealth Scan is to use the sudo with the other user you are currently assigned to. So the other thing is that Stealth Scan doesn't complete the TCP three-way handshake. So basically, once it receives a certain response from the server, it tears down the connection. It ends the connection. That's the hallmark of the TCP Connect Scan. It's the actual opposite of the TCP Connect Scan. In TCP Connect Scan, we complete the TCP three-way handshake, synchronization, acknowledgement, and then sync acknowledgement. But here, we send synchronization packet from our machine. We receive acknowledgement from the host that the port is open, and then we send reset packet to the machine, ending the connection. So once we receive a synchronization acknowledgement from the machine, it means that the port is open. Let's see if the IP is ready. No, yeah, the IP is ready. Let's conduct a scan. Now, sometimes there's an anecdote that the Stealth Scan is useful if you want to evade firewalls. Sometimes it might work against stateless firewalls, but if the firewall is stateful, it just doesn't work. Let's go here and find the available flags. So UDP scan can be conducted using -s uppercase U. And to help the scan, you can execute -f as well to make the scan faster. Now, what's the difference between a UDP scan and a TCP scan? Basically, in UDP scan, it's very difficult to learn the status of the port, because UDP is a connectionless protocol, and therefore we don't expect a response from the server or from the target machine on the status or regarding the status of the port, whether it's open or not. But if the port is closed and you have issued a UDP scan, in that case, to know if the port is closed or open, the machine will give you an ICMP port unreachable if the port is closed. So that's the hallmark of a UDP scan. UDP scan, if the port is closed, it's going to give you ICMP port unreachable. But if the port is open or is filtered by the firewall, Nmap just cannot find out. If I go back here to the list of notes, I have categorized or organized the type of scans and the purpose of every scan in my notes. If you have subscribed to the channel membership, you have already got access to these notes. These notes are part of the Google Drive notes, not the online portal, by the way, for subscribers or for those who have subscribed. Now, as you can see here in this section, I mentioned UDP scan somewhere. Let's see. Yeah, UDP scan. So as you can see in UDP scan, we also control the timing. I'm going to talk about the timing later. But basically, guys, there are some things we have to put in mind. The first thing is, let's see. Scroll down. Some other general notes. Yeah. So what about -t? We see sometimes we use -t in scans. -t is used to control the speed of the scan. Okay. So 0 being the slowest and 5 being the fastest. So slowest 0 and 1. So 0 and 1 paranoid and sneaky, actually I used to evade IDS and firewalls because the scan will be very slow. The interval, there will be a huge interval between every packet that's sent to the ports, like 5 minutes between every port. So if you are scanning for like 100 ports, multiply 100 by 5, and you will have 500 minutes needed to finish the scan. That's why it's very useful if you want to evade firewalls and if you have time. Now T5 and T4 are the fastest, and they are the most aggressive and the most noisy. Don't use them if you want to evade firewalls or IDSs. Now, if you want an alternative for the timing, you can use something called the minimum rate. So basically here we control the rate of the packets. For example, you can specify a number of packets using -- minimum -rate, or a number of packets, or a maximum number of packets to specify -- max -rate. For example, as you can see, -- max -rate 10, ensure that the scanner doesn't send more than 10 packets per second. Okay. Now you can use this one or this one for the evasion of firewall. I finished. Let's go over the scan. As you can see, the output kind of differs from the output we received when we conducted TCP scan. So as you can see, we now have a new state, filtered and open. So here Nmap doesn't know the actual real status of the report, whether it's open, whether it's filtered. Why? Because UDP is a connectionless scan. So unless Nmap receives a response other than ICMP port unreachable, it cannot determine. So basically here on this scan, it hasn't received a response. Here also it hasn't received a response, open and open. But when you see this one, it means that Nmap couldn't determine the response from the server because it's a connectionless scan. Now, when you see a closed port here, it means that the Nmap received ICMP port unreachable. So if Nmap doesn't receive ICMP port unreachable, it means the port is either open or filtered, depending on the presence of firewall. Let's see how we can use that. So Nmap -SN. That's how we use null scan. And it is called null scan because all the flags are set to 0. The TCP flags, the synchronization, acknowledgement, reset, push, all of these flags are set to 0 by Nmap. That's why it's called the null scan. And then we specify the IP address of the port. So basically a TCP packet with no flags, right, will not trigger any response when it reaches an open port. So basically, same as UDP scan or similar to UDP scan, the response from the server will be like nothing. It won't trigger any response because the flags are set to 0. The flags needed to complete the TCP three-way handshake are here set to 0. That's why it won't trigger any response when it reaches an open port. So what does that mean? It means that when we don't receive a response from the server, it means the port is either open or filtered because of the firewall. Now what happens when the port is closed? Nmap receives reset packet from the host. The IP is here. You don't need to memorize these details, right? But it's essential and tremendously beneficial to understand how the three-way handshake works for every scan and what are the flags set for every kind of scan. So again, in case of null scan, we send the flags. We set 0 is set to all the flags, and if the port is open, what's going to happen? Nmap won't receive a response. If the port is closed, the server will send a reset packet to Nmap. That's how Nmap will determine whether the port is open or closed. Now, also additional note that similar to UDP scan, if Nmap doesn't receive a response, it means that the port is either open or filtered, depending on the firewall. So in that case here, looks like there was a firewall blocking this port on port 68, but these ports were not blocked. Now another type of scan, let's launch a new tab, not to waste time. And here, zoom in, zoom in, zoom in. So the other type of scan here is the finalized scan, or -SF. So Nmap -SF. So similar to the null scan, no response will be sent from the server if the port is open. It's the same as null scan. If the port is closed, the server or the machine or target machine will send you a reset packet, meaning that the port is closed. All right, let's go over the results. As you can see, we get something similar to the above. Open, filtered, open, filtered, open, filtered. It means that on these ports, Nmap has not received any or has not triggered any response from the server on these ports. The server didn't answer when the Nmap probed for these ports. That's why Nmap determined that these ports are definitely not closed. They might be open or they might be filtered. But most probably when you see this, means that there is firewall blocking these ports. Now the finalized scan most probably will get results similar or output similar to the null scan. Open new tab, and we will start the Xmas scan now. I'm going to tell you guys what is the purpose of these scans. Okay, so Nmap -SX. So an Xmas scan, or the Christmas tree lights scan, it actually sets the find, the push, and the urge flag simultaneously. That's what happens. The 3 flags are set here to in the Xmas scan, not the null or not the finalized scan. So similarly here, guys, when the port is open, we will not receive any response from the server. But when the port is closed, we can receive reset packets. All right, let's see here. Yeah, this one is finished. As you can see, results similar between the SYN scan and the null scan. Let's test out the Xmas scan. So paste and run. Now, when we will use these 3 kinds of scan, the finalize, the null, and the Xmas, do we use them to evade firewall? Of course not, because technically here we are not evading firewall. As you can see, these ports appear as filtered. So why do we use them? We use them to figure out the firewall rules. So we want to find out if there is a firewall in place, what are the rule sets of the firewalls. We launch these scans. We try to probe if we get some sort of filter in here. It means if we get filtered on the ports, it means there might be some firewall in place, which will help us craft our scanning strategy. It means that we have to evade firewalls if we want to get more information about every certain service here. That's why we use them. Similar to these scans, the Xmas, the SYN, and the null scan, the acknowledgement and the window scan can also be used to determine the firewall rule sets. SA for acknowledgement scan. Acknowledgement scan sends an acknowledgement packet with an acknowledgement flag. So this means that this packet is kind of missing. For that reason, the server will respond with a reset flag, regardless of the state of the port. So if the port is open, closed, or filtered, or unfiltered, it's going to send you a reset packet. So there is no way to know the status of the port here. It is just to learn if there is firewall. So what you can do here, you can launch the scan and learn the status of the ports. Similarly, with the window scan, it's the same. But in the window scan, we get to know we get to examine the TCP window field of the reset packet returned by the server. Now this, sometimes it reveals whether the port is open or not. Let's see here. Let's go back to acknowledgement scan. Look at this, unfiltered. So unfiltered, what does that mean? It means it could be either open or closed, right? We haven't determined the status of the port, right? We just determined that if there is what kind of firewall rule set in here. So it means that the firewall doesn't block these ports. So it might be safe to proceed and scan these ports specifically and be aggressive somehow using the version detection or OS detection as well. But if they appeared as filtered, it would have been much beneficial to start further scans with firewall evasion in mind. Now the same we can do with the window scan. So -w in this case. Now the difference here, as I told you guys, is in window scan, we will be able to examine the window field. And examining the window fields in some systems can reveal if the port is open. Okay. Let's take a look here. So we have these ports closed. So Nmap was successfully able to determine the status of the port by virtue of the window field. So basically Nmap received a reset packet from the host, that's true, but upon further inspection of the window field, it was able to determine that these ports are closed and yet not blocked by the firewall as well. So with firewall evasion, we have multiple options. The first one is to use stealth scan, but make sure to use the timing. So -T1 and -F fragmentation. We're going to talk in details about fragmentation, but for now, you can use a couple of these techniques. Stealth scan, okay, and then you're going to use T1 for a sneaky scan. It means it's going to wait like average between 3 to 5 minutes between every port. So you can use the scan maybe if you have time to wait for the scan to finish, or if you have a few number of ports. -F for fragmentation. Fragmentation is the technique used by Nmap to fragment the TCP header into multiple bytes. Whatever TCP header is 24 bytes, right? So it will fragment the TCP header maybe to a number of packets, where every packet contains around 8 bytes or 4 bytes. That's the first technique. Unfortunately, we don't have a way to test this because in the current rooms they don't have firewall implemented, so there is no way to find out if this is successful or not. But these are techniques that I attempted and tried by myself. The other way is to perform a decoy scan. Decoy scan is the ability or technique where you use a pool of IP addresses and you make them appear as the IPs that perform the scanning. This means on the target machine or in the logs or any other place, the administrator of the machine will see that these IP addresses 1, 2, 3 have performed the scan, not only your IP address. It's a beneficial way to obfuscate or to distract the administrator from the real IP that has performed the scan. But you have to include your IP address in the scan, and you can control the order. For example, you can use IP1, any IP you want. It will be the first IP that scanned the host. Then IP2 is the second IP that scanned the host, and lastly, this is your IP address. You can put your IP first or next, or you can put as many IP addresses as you want, and use -D option. If you don't have an IP address in mind that you want to use, you can use the RND or random. Random will generate IP addresses for you. Look at this one. -D, this is a given IP address, another given IP address, and then we use RND. To tell Nmap, you can generate IP addresses and put them as the IPs that have performed the scan. Again, we have our IP at the end. That's a decoy scan. It's very popular to evade firewalls, especially that if your IP is blocked or somehow has been added to a blacklist. But it's actually kind of more meaningful if you use the scan maybe to obfuscate your identity. You don't want to be tracked, so you use multiple IP addresses. Other technique that's used to spoof or to evade firewalls and IDS is the spoof to scan. So in spoof to scan, we pick up an IP address for a machine that we are aware of or we have visibility over, like in the network. And this is the command. So what happens here, we switch the interface, -PM, we disable the ping, and -S, and then the spoofed IP address. For this scan to be successful, since we don't have control over this IP address, we're not going to be able to determine there will be no output. Why? Because the machine will send the response of the TCP flags to this IP address, not your IP. So we will not be able to collect the output. You will have to have a sniffer running, right, on this interface, and then Nmap will be able to tell you the status of the ports based on the communication or based on the packets exchange between the target IP and the spoofed IP address. So if you don't have visibility, or if you're not on the same network of this IP address, like the same Wi-Fi or the same corporate network, it's not gonna be successful. Fragmented scan. In the fragmented scan, I said earlier, guys, we fragment the IP data or the TCP header into 8 bytes or less. So we use -F to perform fragmentation of the IP packet, specifically the TCP header. If we use -FF, what's going to happen, as you can see, instead of splitting the data into 8 bytes, it will split them into 16-byte fragments. Instead of -FF or -F, you can use -MTU to specify the minimum transmission unit. If you don't want to bother with details, just use -F or -FF to perform fragmentation. Now, this is another technique I have used in the past to change the user agent. So basically here, what I did, -SV to perform version detection, and --script-arguments. Here, I use a specific user agent to perform the scan, to fool the firewall. Again, another method to evade firewall is to control the timing. For me, controlling the timing is the most important piece here, because IDSs and firewalls rely on the intervals between every packet sent by the source to determine if it is kind of suspicious or not. So that's basic. Try to choose T1, or at max you can choose T2. And then you can pick up one of the techniques, like you can choose to fragment the scans, or you can choose to have a decoy. Here we're going to start the version scanning. So Nmap -SV. So here we say to Nmap that we need to perform an Nmap scan and detect the version and grab the banner of every service detected on every open port. Like -T1, for example, and -F. Okay, at least because -SV, the version detection here, in order to grab the banner and the version of every service, Nmap will need to perform the TCP three-way handshake to complete the connection. Otherwise, it's not going to be able to grab the banner and determine the version. That's why this type of scan doesn't work with the stealth scan, because stealth scan doesn't complete the three-way handshake. So meaning you cannot do -SV-SS. It doesn't work. All right, let's put the IP and see what kind of services we have along with their version. Now in a separate tab, these are the status of the port, the protocol, the service, and the version. Now the version and the banner are beneficial if you want to find out if the set version is vulnerable, or if it has a CVE publicly available, and if there is a matching exploit for that. Very beneficial for pen testing. Now let's talk about the scripting engine. So Nmap scripting engine enables you to use Nmap Lua scripts, or scripts created in Lua language, to extend the functionality of your scan. Meaning, with Nmap scripting engine, we can perform brute force, we can perform discovery, we can perform DOS attack, we can perform exploitation, we can perform fuzzing, so on and so forth. We can turn Nmap into a vulnerability scanner tool like ACK or Nessus or OWASP. We're not nearly as these, but it can have a bit like of functionality for them. So Nmap, or all of the scripts that Nmap or uses actually, they are under cd user share, and then Nmap, I guess, script, yeah, ls, and we have all the scripts as you can see here. If you want to use a specific script in your scan, you have to put the name of the script. Now you have three options. We can either use the default option, this one, nmap -- script equal default. This will use the default category of the scan, like it will conduct discovery, exploit, external fuzzing on the target. If you don't specify a name, why it's not working here? Okay. So -sc. Yeah, here. As you can see, we have now more extensive results, more detailed output. So we have the port open, we have the service running, we have the version, and we have the SSH key. As you can see, we've got the SSH keys here. Again, we have here for the SMTP, we have more details. We grab the banner, the version, the domain, so on and so forth. What we're going to do, we're going to say ls grep robots. This will give us the name of the script. Now, if we cat scrolling up, we will check the description to find out what it does. So here, up. Checks for disallowed entries. Saving the Nmap output. Saving the Nmap output, guys, is very important when you have multiple targets in a pen test engagement, or you know that or you are aiming for a long output. So it doesn't look neat if you leave the output on the screen. I know I do it. I leave the output on the terminal without wrapping this in the output file. I do that in CTFs, but it's just a CTF, right? So there are three types of Nmap outputs we can use. The first one is normal output. So Nmap, say -sv, then the IP address, and we use -on, and the file name. Say it is output.nmap. So I saved the scan, okay, in a file named output.nmap. Now the normal file, it's just normal. There is nothing unique about it. The other beneficial one and useful one is the greppable format. The greppable format allows you to use grep and perform some filtering on the file. So you can do that using -o-g and output.g and then nmap. This is the other type of the output. This will enable you to use grep on the output. If you want to grep ports, grep protocols, grep versions, grep CVEs, grep IPs, you can use this one. I highly advise this one in real case scenarios or real engagements. And the last one, if you want to use the Nmap output on multiple programs, it's preferred if you use the XML format. -x, and then you name the file. You can say nmap XML. Okay, all right. So the first thing we're going to do is to scan for the host. We want to check if the host is live, and we want to check what are the services and the open ports. So we start with sudo nmap, and then we select what we want to do. The first thing I'm going to do -p indicating that I want to scan for all the ports, because this is an unknown machine to me. I don't want to skip or miss any port. That's why I want to scan for all the ports -p. We just want to list the open ports, and then based on the information we get from the output, we tailor the scanning to be more detailed toward one of the scan ports. So to make the scanning faster, what we can do -t, and we can select or control the level of noise of the scan. So starting with 1, it is it's very calm scan. 2, we go up in noise. So basically, I'm going to go with T4 because we are not scanning a secure network. We are scanning an open network. It's just a network for testing, so it doesn't affect the quality of the testing. That's why if we go up in speed with the -t option, just put in mind that this is a very noisy scan. Now, if you're scanning a real network, it's recommended if you start with T1 or T2. So let's start with T4. Okay, so this is the result of the Nmap scan. As you can see, we have got a lot of open ports as well as filtered ports. Now, we have 22, SSH, 80, 443, and there is something running on port 1338, and another service running on port 1443. We've got also this. We have actually enumerated the web server running on this port, and I've discovered a directory which led to the flag. And we have got this. All right, so we are interested more in learning about the FTP server. So let's go ahead and see these two ports. We want more details about these ports, so we're gonna say sudo nmap-b, and the port is 1338-SV. What is the service running there? More information about the service and the version. And we've got port 1443. So let's go ahead. (1443), and let's name this as Nmap 2. So on this port, did I copy the port correctly? Yeah, no. I think I have typed this wrong. So it's 1443. I don't know why it is 33. Okay. So as you can see, guys, on this port, there is indeed an FTP server running. And this is the version of the server. We can try to interact with the server and grab the banner by trying to connect to the server. So we type FTP, followed by the IP address, and then we specify the port 1338. If you don't specify the port, it will connect by default to port 21, which is the designated port for the FTP servers. Now, when you connect, you are greeted with the flag, right? Usually, guys, this is the banner of the FTP server. Now, you might try to go ahead and log in, maybe using anonymous credentials. Anonymous. Now, if anonymous logging is enabled, no, it's not enabled. So you cannot log in as anonymous. So basically, when anonymous login is enabled, you'll be able to use anonymous credentials. Anonymous has the username and anonymous has the password to log into the FTP server. But these settings are not enabled on the target machine, so that's why we couldn't log in. Now, this is the flag for the service, for the question. And basically, this flag represents the banner. Let's go here and see what is the other service running on port 1443. So it is another web server running here. It is Apache, and this is the version. Let's go ahead and visit this page, see what is running. This is a bad request. Your browser sent a request that the server couldn't understand. All right, let's go back to the main port scan. So we have a web server running on port 80, another one on port 443, and port 1443, and the last one on port 8000. So which one of them is the one that has the PHP extension enabled? How do we find out? Let's go ahead and do this scan. Exit sudo nmap-b. I will specify the ports 80, 443, 1443, and lastly 8000 dash. And we specify -a because we want to get all details about these ports. And then we specify the IP address. All right, so now we get more details about every one of these servers. So on port 80, the web server software is light hey HTTPD, and this is the version. Okay, another one running on port 443, the version is 24441, and it is Apache HTTPD. And this is the information, the details about the request that got sent, and the response was forbidden. Scrolling down, we have got this one running also Apache, the same version. And here we get interesting information, such as the PHP version. Yeah, so this is the PHP version 7.4.3. That's the benefit of doing detailed Nmap scan. You get more information, more than just the ports open and the services. So this is the PHP version, and this is the PHP info. So most probably, it is the server running on port 1443, the one that holds the PHP extension. So now we know what is running on these ports. We still got this one, 9007. It says it's OGS-client. Now, let's go ahead and scan this port in details. 9007. You can try to visit this port or this page, 9007. Going to advanced. So there is a web server again running on this port. Welcome to my blog. And it is screaming WordPress, as you can see. If we can go to the source, we can find out. So search for WP dash, and indeed there are instances or there are directories that indicate this is a WordPress installation. So indeed, this is a WordPress installation here. So that's the content management system running on the server. That's how you find out. But this is guesswork, right? You can still find out using the port scan. So this is the result, a web server running, but there isn't much details about whether this is a WordPress or another server running or other content management system. So how do you find out? You go here to the web page, we search through the source code. You can also try to visit the admin page, wp-admin. If this was a WordPress, it would redirect you to the administration login form.